The world is rapidly shifting towards electric vehicles. Governments offer incentives to encourage adoption. Automakers are constantly unveiling new models to meet the growing demand. Consumers are eager for a greener alternative to gasoline-powered cars, hoping to reduce their carbon footprint and contribute to a cleaner environment. This transition to EVs is often hailed as a crucial step in combating climate change, with promises of reduced emissions and cleaner air in our cities. But is it truly a sustainable solution? There are questions that need to be addressed. While EVs produce zero tailpipe emissions, the production of their batteries raises serious environmental concerns that cannot be ignored. The mining and processing of raw materials, along with the manufacturing process itself, come with a significant environmental cost impacting ecosystems and communities. To understand the true impact of EVs, we must delve deeper into the hidden costs of their batteries from extraction to production. This essay explores the environmental implications of EV battery production, shedding light on often overlooked aspects. We will examine the extraction and processing of key minerals, the manufacturing process and the associated environmental impacts, and the challenges of recycling these batteries at the end of their life cycle. By understanding the full picture, we can make informed decisions about the future of transportation and our planet, ensuring a truly sustainable path forward. The shift to electric vehicles is driven by the promise of a cleaner, more sustainable future. However, this clean energy solution relies on a dirty secret: the extraction and processing of rare earth minerals. These minerals, essential for EV batteries, are often mined in countries with lax environmental regulations. The mining process itself is energy-intensive and polluting, leaving behind a trail of environmental destruction. Deforestation, habitat loss, and water contamination are just some of the consequences. Furthermore, the transportation of these heavy materials across continents adds to the carbon footprint of EV batteries. The environmental impact of mining these minerals is often overlooked in the rush to embrace EVs, but to truly evaluate the sustainability of electric transportation, we must acknowledge and address the hidden costs at the very beginning of the supply chain. Lithium, often dubbed white gold, is a key component of EV batteries. Its high energy density makes it ideal for storing electricity. However, the extraction of lithium comes with a hefty environmental price tag. Most lithium is mined from brine deposits found in salt flats, primarily in South America's Lithium Triangle. The extraction process involves pumping vast quantities of brine to the surface, where it evaporates in massive pools. This method consumes enormous amounts of water, a precious resource in these arid regions. The process also contaminates groundwater with chemicals and heavy metals, threatening local ecosystems and communities. As demand for lithium skyrockets, so does the pressure on these fragile environments. The race to extract this white gold is leaving behind a legacy of environmental degradation and social conflict. Cobalt is another critical mineral used in EV batteries, prized for its ability to enhance battery performance and lifespan. However, the majority of the world's cobalt supply comes from the Democratic Republic of Congo, where mining practices are often associated with human rights abuses and environmental devastation. Artisanal cobalt mining, often involving child labor, is rampant in the DRC. Miners work in hazardous conditions, exposed to toxic dust and lacking proper safety equipment. The environmental toll is equally alarming, with deforestation, soil erosion and water contamination plaguing mining regions. The ethical and environmental concerns surrounding cobalt mining cannot be ignored. Responsible sourcing and ethical supply chains are crucial to ensure that the transition to EVs does not come at the expense of human rights and the environment. Section 5. Nickel. From mines to toxic wastelands. Nickel is a key ingredient in many EV batteries, contributing to their high energy density and long lifespan. However, nickel mining and processing are notorious for their environmental impact. Open-pit mining, the most common method of nickel extraction, leaves behind massive scars on the landscape. The refining process is equally damaging, releasing toxic chemicals into the air and water. These pollutants can contaminate drinking water sources, harm wildlife, and contribute to respiratory problems in nearby communities. The disposal of mining waste, often containing heavy metals, poses a long-term threat to the environment. The environmental consequences of nickel mining highlight the need for stricter regulations and sustainable practices throughout the EV battery supply chain. Reducing our reliance on nickel through battery innovation and responsible sourcing is essential for minimizing the environmental footprint of EVs. Section 6. The high cost of battery production. The manufacturing of EV batteries is an energy-intensive process requiring significant amounts of electricity and resources. From the extraction and processing of raw materials to the assembly and transportation of finished batteries, each stage generates greenhouse gas emissions. The carbon footprint of battery production varies depending on the energy mix used in manufacturing. Regions relying heavily on fossil fuels for electricity generation will inevitably produce batteries with a higher carbon footprint. Furthermore, the use of hazardous chemicals and the generation of industrial waste during battery production raise concerns about pollution and resource depletion. Efforts to decarbonize the electricity grid and improve the energy efficiency of battery manufacturing are crucial to reducing the environmental impact of EV production. Investing in renewable energy sources and developing cleaner production technologies are essential steps in the right direction. Section 7. Recycling and the future of EV batteries. As the number of EVs on the road continues to rise, so too will the challenge of managing end-of-life batteries. This is a growing concern for both manufacturers and environmentalists alike. Disposing of EV batteries in landfills is not a sustainable solution, as it can lead to soil and water contamination. The toxic chemicals in these batteries can seep into the ground, causing long-term environmental damage. Recycling these batteries is essential to recover valuable materials and reduce the need for new mining. This process not only conserves resources but also helps in reducing the carbon footprint associated with battery production. Recycling EV batteries is a complex process requiring specialized facilities and technologies. These facilities are equipped with advanced machinery to safely and efficiently break down the batteries. However, it offers significant environmental benefits by reducing the demand for virgin materials and minimizing the can lead to more effective recycling methods. Government policies and industry initiatives can incentivize battery recycling and support the development of a robust recycling infrastructure. Collaboration between public and private sectors is key to achieving these goals. Section 8. Weighing the pros and cons, a necessary evil. The transition to electric vehicles is often presented as a clear-cut solution to the environmental challenges posed by gasoline-powered cars. They are seen as a beacon of hope in the fight against climate change. While EVs offer significant advantages in terms of reducing tailpipe emissions and combating air pollution, they are not without their own set of challenges. The environmental costs associated with battery production cannot be ignored, as they pose significant ecological concerns. The mining of lithium, cobalt, and nickel raises concerns about habitat destruction, water consumption, and pollution. These activities can have long-lasting impacts on local ecosystems. The manufacturing process itself is energy-intensive and generates greenhouse gas emissions, which contribute to global warming. However, it is important to note that the overall environmental impact of EVs is still lower than that of conventional vehicles over their entire life cycle. This includes the emissions from production, usage, and disposal. The key takeaway is that the transition to EVs is not a simple trade-off. It involves a careful consideration of various factors. It is a complex issue with both environmental benefits and drawbacks. Each aspect must be weighed carefully to understand the full picture. To truly achieve a sustainable transportation system, we must address the environmental challenges associated with EV battery production. Only then can we move towards a greener future. Section 9. The road ahead. towards sustainable EV production. The environmental concerns surrounding EV battery production highlight the need for a multifaceted approach to ensure the sustainability of electric transportation. This includes promoting responsible mining practices, investing in battery recycling technologies, and decarbonizing the electricity grid. Governments, industry leaders, and consumers all have a role to play in shaping a more sustainable future for EVs. By supporting policies that promote ethical sourcing, incentivize recycling, and accelerate the transition to renewable energy, we can pave the way for a cleaner and more sustainable transportation system. The road to sustainable EV production requires collaboration, innovation, and a commitment to addressing the environmental challenges head-on. By working together, we can harness the potential of electric vehicles while minimizing their environmental impact, creating a cleaner and more sustainable future for generations to come.